academia, as researchers, and those of us who deal with these questions. So I will leave us with this. Thank you for listening.
Okay, now if you have some question, remarks. Okay, your name.
I'm Marco Tronfi, a master student in Padova University. Uh, International Relations and Diplomacy. I don't understand or agree with the definition of like the statement of the nation state that is failing because it's too broad of a term in my opinion. I think that the idea of the liberal state the West have is failing or is not up to date anymore. It needs a reformation, but I think that the nation state as China or Indonesia, South Africa, Brazil, other countries, not Western, necessarily Western, or not necessarily completely liberal or following the idea of a liberal state that Western country has, are not having the same problems that we have. The information is used in a different way, is perceived in a different ways, and it works. It works means that is efficient. The state can control it, and it's not an issue. Is something that can be managed by the state or control or has an impact, which in the liberal view of information, it is a big deal because it's hard to control, it's hard to use, and it doesn't influence as much as as much it does in other kind of states or institutions. In China, public opinion is influenced by media, and media are not completely probably, or maybe some are, some not, because I don't know. I don't know enough to give an opinion on that, but for sure it works. So I think that when we say that international relations and state actors are less relevant now, I see the issue. I see that it's true partially, but it's partially because in the Western countries is like that. So it's not, the problem is not the international system, which is on a crisis, and the state that is on a crisis, but it's the liberal state and the liberal view of what a state has to be and how people has to live in a certain democratic or Western world. So I want to underline that because I think that the problems that you're pointing are a thing, are real, but are real only for part of the globe, which for us is really relevant and it has to be studied, it has to be fixed and debated. I just want to underline that that this is has a political interest for us, because to be relevant and to remain relevant, we need to fix these things, because our country, to be influential, needs to fix the problem with the information and public opinion in general. Another thing that I want to add is that probably the issue that our state have is a problem of how big they are. They're just too small. The European countries are too small. They're not influential enough. They cannot be. They cannot access economia di scala, which is in English scale economies. And so to control information, or at least like making information useful, and to control enterprises, other actors besides the states, they need to be together, because the United States are, I'm not saying that information in the United States works, but at least the state has much more chances to control it and to manage it. The problem with the European Union is that it doesn't even have the capabilities to influence enough and to act, in my opinion, of course. And so I wanted to underline that, just to set the stage for the debate. I think it should be a Western problem that should be seen as in this way. Thank you.
Thank you. I do. Would you like me to respond or?
Yes.
Yes, of course. It was very insightful. Thank you for that. Absolutely. Yes, I totally agree with you. I think the question is not that we respond to these issues in the way that we should, but I think what I was trying to mark here was what's happening. How do we respond to these things? Right? Because you raised one very crucial issue. Could you repeat that?
How do we respond to that in remaining in the liberal view of the world and what the state has to be? Because the other answer can be let's just become not democratic country, let's control the information completely. So the point is that how do we fix the system without changing it in an ideology that doesn't represent?
But that's exactly the problem, isn't it? Because we're not a task force here. We cannot fix the problem, but the problem is there. So I'm not saying that we can fix the problem this way or that way, but I'm saying the problem is there. The nation state is a problem. It is a problem. We invented that after the Industrial Revolution. It's the most complex political system that we ever invented. It's there. And we do not need to reinvent the wheel. I believe we can fix it, but right now it's not functioning. It's not functioning. So what do we do about that? Go. More go. Yeah.
We have time for the liberal.
If you
Go.
what I think is that the nation state is working. It's just not working in the liberal democratic way, because I think China is a nation state, maybe a bit not only like.
How do you define working?
Working means that
it
the
working?
institution of the country can influence what happens, maintain their sovereignty inside their territory. So they can influence their enterprises, they can influence the population, they can influence information, they let them pay taxes, they can defend themselves.
That
Yeah,
means they function.
Functioning is like
Function, but
sovereign.
working.
I think in China
Is it working for the greater good?
depends on what good is, and depends on what you define as a nation state also, of course. But I think that
I think those are the kind of questions that we're facing right now.
yeah, but I don't
I'm a
think that in
political
China they're doing the
scientist
same.
by training.
Sorry. Mhm.
I'm just going to say this, and I work with historians for the last 25 years of my career, and they say, and I believe them, and I've seen it myself studying history, every 50, 60 years, there's an upheaval.
Mhm.
And I think we're having that upheaval right now. And what do we do about that? To me, that's the question. And I might be wrong. I might be too provocative. I might be too, I don't know.
Mhm.
But I honestly, personally, as a scholar, believe in the fact that we came to the end of the late modernity in terms of thinking of modernity, and the nation state formation. And we need to think, is it representing everyone? is it representing our best interests? And whose best interests is the nation state representing right now? Youth, indigenous people, men, women, other sexualities, etc. So yeah, I think we're at a crossroads.
Yeah, my point of view is the same. Like there is an upheaval, there is something that we have to, of course, discuss. What I'm saying is that probably in China they're not doing the same debate because they don't see the problem, because they are not having it, in my opinion. Like it's a Western problem, is a change that is affecting countries, some in a good way and some in a bad way. We are the one who's dealing with in a bad way. So in my opinion, the only thing that we have to underline in this issue, which is a real issue, is that is affecting us because our view or our idea of what's good, how should a state work, and how a country should be influential, in which way, by using what, is not working anymore. But there is, I think, is working. But that's just my point of view, and that's what I think that debate should be
Thank you
about.
for
But
that.
that's it.
I think we need to.
Yeah, no, but I see your.
We have a question by Alessandro.
It's not a real question, I just point on this subject that
But here, please, Alessandro Pascolini, the next.
I just want to point out that the same applies also to China and to Russia. According to some scholars that are considering the fact that we are going in a neo-medieval system of international relations that include the failure of technological and national states, and this applies to all over the world,
Yes.
practically including Russia and China. This is just to remind that there is this school of thoughts going around, considering
Absolutely.
the present change to some neo-medieval system of political interaction in the world. Thank you.
Thank you. That was absolutely so insightful and valuable, what you said. Yes, we don't even know what's going on there, do we? No. We only know what's going on from our part of the world, the Western side of the world, the Northern Hemisphere, the Western Hemisphere. So we do not know what's going on there. But nevertheless, things are going on there. And whether they speak to each other, are they on par with each other or not, we don't even know that. But I think what we know is that the balance is changing. The balance is changing because we are used to thinking the West against the rest, but it's not the case anymore.
But in the rear of the room, what do you think? Because I don't
Yeah.
know if you are participating in a course of ice cream production or European Global Studies, because they are speaking about the present situation, the system, no? With the balance of power. And frankly speaking, I think we are not in a new Cold War. We are in a new, not in a new system. We have seen this system in the history, and now the problem is that we have some elements of science and technology, and they are very powerful, and we risk to have also too much quick changement. I agree that the Western part of the war must review several values and dialogue. For this is reason, when we went in Arctic Circle the last week, we have several panel with not autochthonous, but with indigenous participation. Yes, but we had also a very nice, very strong intervention by the Rear Admiral, US Navy, responsible for NATO defense in Arctic. And I guarantee you that it was a real strong, hard discourse about security and defense. We have no Russian, sure. We have some Chinese delegation. But anyway, the present critical situation was so present in all debates, security, the relationship with the USA. We were hosted by a country, how many inhabitants? 58 millions islands. Not 300,000, 50 inhabitants. For us, this is important. When I stay in touch with my colleague in the north of Europe, I must explain that we are managing a country of about 60 millions of inhabitants with a complex history, no? And this start from the nation state, but we are in European Union and we try to understand also which are the limits, but also the big opportunities of European Union. The previous intervention is a little example, only on heritage, but the methodology, the pathway is the system. Science diplomacy, I repeat, I think that is a Western concept. I don't know if in the east part of the world they are studying science diplomacy. They are managing science, technology, and foreign policy. In the next session, we will have a communication about semiconductor, microelectronics, and the clash between USA and China on this product. The problem is to try also to have several arena of dialogue, exchange of different values, of different policies. But we must have always a critical analysis. And I think this is an example.
May I say something?
Yes, but if you want for finish.
Yes. Of course, as I said before, we do not need to reinvent the wheel. Nation state format is the most complex system. We should maintain it, but are we communicating in the way that we should within the nation state format, within one nation, in terms of what our stakes are? Well, I can tell you, for instance, in Sweden, those of us, those communities who live up north, the Sami, are their interests being represented in the nation state politic? So what I'm trying to say to you is that I'm not going against the nation state format. On the contrary, actually, we should not. But we should try to reinvent it in a way that we can deal with the kind of planetary crises that we are going through today, and considering all these constituencies, all these people who are not represented in the nation state format.
But I'm sorry, perhaps I'm too much realistic sometimes, but at the present time, there are many ideas, many items, many subjects that they are not considered, no? At international level. We are living in a very difficult period, like in the past, we have a real balance of power system. But I agree that we must to represent also the minorities or starting from another another philosophy, another approach, a real global approach, where we are considering also several local realities and several national interests, in the sense also like for Sami or for other, this is one example, Inuit, we have several indigenous in the Arctic, but which is now the reality of the indigenous in Russia. This is not the same that for Sami in the Scandinavian country, for instance, no? Yeah, or no?
May I respond?
Yes.
Very quickly, I very much appreciate your insights. And in some ways I agree with you, but in some ways I don't.
Yes, but this
Of
is
course, but that's what it is, right? I think we have come to a point where we cannot just say like, okay, whatever we can get out of this, we should get out of this. I mean, there are stakes very high in these national debates, like Sami, other indigenous populations. We cannot just say like, okay, yeah, okay, we saved the indigenous, we saved the nation state format. Yes, of course, yeah, we should. But at what cost? At what cost? And what goes in there? I think we should be a little more vigilant and, dare I say, vicious in terms of including these people in there. Because otherwise it's not gonna cut it. Not for me. Not for me, and I know not for them, definitely not. Many people around the world, no.
For this reason, for us, this was the reason why I went in Reykjavik at Arctic Circle Assembly. The idea was to say we want to have Arctica and Antarctica in our schools, in our courses, because this is a very useful example also of this question, no? Why we must to consider the indigenous voice when we speak about geopolitics, and at the same level with, because this was one of the panel, no, in the assembly, why consider the indigenous position at the same moment with, for instance, U.S. delegation, U.S. ambassador, no? So that, yes, I agree. And this is one of the reasons why we want to speak about Arctic. Because this is not only a problem for Arctic, we have other regions around the world where these national interests, but national interest starting from little countries, little realities, or realities without power, are without consideration. And one very good, very nice experience is also this of Arctic Frontier and also of Arctic Circle. I was very impressive that not only the indigenous, but also country like Italy or France, we are not Arctic state, we are state, but people came in here, our panel, which was the position of Italy or France, and not only from a scientific point of view in the Arctic, but also starting from this is a political message, no? From this political point of view. I was touched by a Scottish MP who said to me who he was interested to understand why for us, from an educational point of view, it was relevant to speak about Arctics, not only for geopolitical question, not only for technoscience, but I said also because they have this is important experience, taking account also of the indigenous, also of the NGO, also Arctic as a sort of a mirror, not only of the present geopolitical situation, but also for the future. And for me, this was a very nice, very important experience. For this reason, we want to organize in 2026 a lab on Arctic and Antarctica. And if it's possible, to bring there some selected students. Because it's sure to stay with you, now we finish the panel, but to stay with you, to speak with you, the people that we met in Svalbard Island, no, in Longyearbyen,
Oh.
with the beer very cheap, about 35 euros a glass. This guy was very, very interesting, no? We exchange, and I think this is a very nice, very little, very selected experience. But the idea is to bring there also some Italian students, not only PhD, but graduated students, because this example of debate, we must
Should continue to have this.
yes, this debate, but also starting from the university.
Yeah.
Okay, and with different point of view. Now we open the new panel, thanks. And we invite Benedetto Zaccaria, Alessandro Pascolini, Francesco Crespan to came here. Grazie.
Grazie. Grazie.
Yes.
Okay, so good afternoon to everyone, dear colleagues, dear students. We are opening a new panel, which is devoted to the international activities of the International Institute of Nuclear Physics, which is an Italian institution about which we will hear about the history from Professor Alessandro Pascolini, and about present-day research projects in which one of the practitioners of INFN, Dr. Francesco Crespan, will speak about. So we will be therefore focusing on a national institution, but looking at its international profile. I would like to say a few words about how this panel was conceived, and I would, taking just one minute, and I would just say that it all started from a research project that has almost nothing to do with science diplomacy, in which I am involved. This is a project financed by the European Research Council, which is based in Slovenia, in Koper, Capodistria in Italian. And this is about interregional cooperation in the Alps-Adriatic region. That is a region that includes northeast Italy, Slovenia, Croatia, and the southern regions of Austria. This community started to operate in the late 1970s as a framework, as a first instance of cross-border cooperation among countries that belong to different systems of the Cold War. Italy was a member of the Western community, Yugoslavia was a non-aligned country, whereas Austria was a neutral country. So when I was studying this community, this Alps-Adriatic community, I started to focus on the activities of the Veneto region, which is one of Italy's northeastern regions, and I came across the transborder activities of this INFN, this Institute of Nuclear Physics. So the question was, why was this institute involved in international activities? And I also realized that one of its directors, Claudio Villi, about whom we will hear in a while by Professor Pascolini, was Willy was involved in very much in international activities, also promoting the international dimension of this institute. This story soon was showing the international role of scientists, of research institutes dealing with science, but opening the way to interregional cooperation, paving the way to interregional diplomacy, and therefore also affecting state relations. So I was discussing this with my colleague David Burigana, interviewing Professor Pascolini about this experience. And for personal reasons, I am also in touch with Francesco Grespan, who is nowadays working for the Legnaro laboratory of the INFN. And the idea was to host here for this panel two witnesses that can deal with the history of the INFN from its origins up to the most recent project. So I would give the floor to Alessandro Pascolini and say a few words about him as an introduction. He is a senior scholar of the University of Padova, where he was formerly associate professor of theoretical physics. He also taught a course on peace sciences at the Faculty of Political Science during the times when Professor Antonio Papisca was an influential professor of this department. And he has also taught courses of armaments and arms control at the European Master in Human Rights and Democratization. His research interests cover nuclear physics, theory, military technologies, armaments control, and history of science and scientific communication, science communication. From 1972 up to 1977, he was scientific secretary at the INFN at the presidency of the institute. From 1988 to 2002, he was responsible for the activities of science communication at the INFN. And he has worked together with the Foreign Affairs Ministry, the European Communities, the CERN, and other foreign institutions, about 60 exhibitions in Italy and abroad on various aspects of scientific communication and about the application of this research. And in 2004, he was awarded a prize for scientific communication by the European Society of Physics. From 1970, he is participating in the activities of the Pugawash conferences on science and world affairs. He is vice president of the International School on Disarmament and Research on Conflicts. And he belongs to the group of working group for international security and armaments control at the Accademia Nazionale dei Lincei. So I'm very glad that you accepted this invitation for something that started originally as a small conversation on the activities of INFN, then it was merged in this broader framework of this international science week on science. So therefore it turned out as an international event. And I would like to thank you for your availability in speaking English. Thank you.
Thank you for invitation. There was some misunderstanding, but you know, I am over 80, so it is accepted that one doesn't understand clearly the point. So I prepared the slides in Italian, thinking to speak only to Italian people, but so I will keep the slides now, but try to present them in English. Perché non va? Cominciamo subito. Okay. The National Institute of Nuclear Physics is an Italian institution, but it is more a community of research more than a formal institution. It studies atomic nuclei, the elementary particles and astroparticles, so-called. It also develops the technology that are needed for this kind of research. Is the point, it is the arriving point, final point of a tradition that was formed in Italy in the 30s around Enrico Fermi in Rome and Bruno Rossi here in Padua. The institution, from the institutional point of view, took a long story, took 20 years to become formal. And the physicists were very clever in navigating in the complex Italian institutional world in order to be able to get essentially what they wanted, to have money for their research. Perché non va? Porca miseria.
Vediamo questo. No, ok.
History starts in 1945, after the war. At that time, there are 4 centers in Italy where young students and researchers join. This is in Rome, in Padua. In Milan, there are 2 different groups, one interested in fundamental research in physics, and the second one for the realization of a reactor for production of energy. And Turin was the 4th center. In 1945, Italy makes a new National Research Council for supporting research in all fields. And the president of this institution is a professor from Turin. And the National Research Council decides to point on centers of study that are living in the university institutes where there is activity, and the National Research Council gives money for research, structure for research, but is not employing personnel. The personnel is all coming from university. For physics, there are 3 centers that are produced. One in Rome with Edoardo Maldi, one in Padua with Antonio Rostagni, and one in Turin with Gleb Vatagin. This new money that is coming from National Research Council allows this center to study the most advanced theme at that time existing in physics, that is the study of cosmic rays. Cosmic rays are particles that come from the sky, and in interacting with the atmosphere, they produce a lot of new particles, strange particles in particular, because they behave in a way not foreseen. And this was the major theme at that time for all over the world. And these 3 groups, these 4 groups in Italy, with the support of National Research Council, concentrate on this kind of research. And they build up on the Mount Cervino a center for a laboratory for studying these particles. This was built already in 1948 and was used by the groups in Rome, Milan, Turin, and Padua. And also foreign groups were using this facility. In 1951, the National Research Council created an institute, a National Institute for Nuclear Physics, just was for the coordination of the activity of the 3 centers of Padua, Rome, and Turin. And with that, it was decided to create a 4th center in Milan, and with the direction of Giorgio Salvini. This institute is guided by a council of directors that was composed by the director of the 4 centers. The researchers are paid by universities, and the idea is to integrate the activity of the centers and prepare the Italian participation to the European accelerator that was discussed to be built. In any case, the amount of money at disposal was not up to the programs that were much larger. And at the moment, in order to study the particles produced by comic rays, the technique was special photographic emulsions. Technology was developed by English, Powell and Blacken in particular, and brought in Italy by Merlin in Padua and Occhialini in Milan. There are events important are very rare, and they are you have to look for them in these in the photographic plates, and with a microscope find and measure and give and obtain the information. You have a kind of what the important event look like. You have to measure, to find first, then measure with using microscope or details and try to understand what was happening. Obviously, it was necessary in order to have a good sample, you have to measure a lot, and so it was necessary to have a special group of people working with the technician prepared to scan these images. And obviously, in order to have a large number of events, it is important, and there was a pressure to have some kind of international collaboration. So from the very beginning, there was a meeting of laboratories interested in the field from all Europe, and it was decided to have a common program of launching balloons high in the atmosphere. The best was to reach at least 30 kilometers high, and the idea was to flow them in Italy because the southern was the better. And so the idea was to build together these balloons, to prepare together the emulsions, and then distribute the emulsion through the participating laboratory, and then collect the scientists in order to produce the physics. Bristol and Padua were in charge of producing the balloons. Rome and Milan had the system of control of the balloon flight. Padua and Brussels made the development of the emulsions, and then there was contact with the Italian Navy and Air Forces in order to follow the operation. The first expedition was in 1952, and the second one in 1953. There were 17 balloons, and some were lost, but 12 were recuperated, and there was an international conference in Padua in April 1954 to present the results. In 1954, there was a much bigger experiment by Bristol, Milan, and Padua. Was 15 liters of emulsion were sent, I quote, and this was the result of this collaboration was able to solve the mystery of the mesons, what we call now mesons K. At that time, they had several different names because it was not clear if it was just one kind of particle, many different particles. So this European collaboration involved Bern, Bristol, Brussels, Cork, Dublin, Glasgow, Göttingen, London, Imperial College, Lund, Manchester, Milan, Oslo, Padua, Paris École Polytechnique, Rome, Turin, and Uppsala. So you see that there was quite a broad European collaboration. Here you see one balloon that is rescued from the sea. Here there is the preparation, the launch of the GSTEC with the participants here. So it was not a surprise to find already in 1952 to have such a broad collaboration, because the so-called atomic physics were constituted an epistemic, what we call now epistemic community. They know, everyone know all the others. They were working on the same problems. There was a very quick exchange of information. There were periodical meetings, and people were moving from one center to the other. The bases were Cambridge, Paris, Copenhagen, Göttingen, and Leida. And they had this guru, they were Einstein, Marie Curie, and Niels Bohr were the persons that were the major point of reference. But the research with the cosmic rays were important, but they were depending on where it was rare to find interesting events. So to develop the research of this particle physics, we needed beams very intense with a lot of particles, with the energy and the nature that were had to be prepared for. In the United States, they were start to build bigger and bigger accelerators, but in Europe, no country was able, had enough resources to produce a good accelerator. So the idea from 1948 to 1950, the idea was to start to have a European laboratory. There was a conference at Lausanne by UNESCO, and in New Oxford, 1950, we decided to work out a project for this European accelerator. And in 1950, the project was approved, and the UNESCO was the institution that was supporting the research, create the conditions for a European. In Italy, the preparation of the project was supported by National Research Council. President of the Research Council, former the president of the council, De Gasperi, speaking of about having 400 million lira for the production, for the Italian contribution to the laboratory, and the same quantity of money for preparing in Italy the experiments. December 51 was decided the venue Geneva for the accelerator, and there was created a council, and the council gives Amaldi the charge to be Secretary General of the organization, and in this way the project of CERN, Conseil Européen pour la Recherche Nucléaire, started. In 1956, start the works in Geneva. There are 12 members, Belgium, Denmark, France, Federal Republic of Germany, Greece, Italy, Netherlands, Norway, and Sweden, Switzerland, United Kingdom, and Yugoslavia. 57 starts the works of the first accelerator. In 59, the bigger proton synchrotron of 28 GeV, this is the unit of measure, was the biggest in the world. In 71, in intersecting storage rings, a new accelerator for making collisions in flight of proton against proton. In 76, the super proton synchrotron able to reach 400 GeV. Then 81 was the anti-proton-proton experiment at SPS. Then 89, the Large Electron Positron Collider, and in September 2028, the present Large Hadron Collider of about around 7 TeV energy per beam. Now you have this is the, this is underground, that gives an idea of the dimension of LEP and LHC. These are the magnets of the accelerator. This is an example for one experiment at one point. And this is described a lot of accelerators that are needed to boost the final accelerator one. At this moment, we have a coup by Amaldi. Amaldi introduced, a meaning change in language. He avoids to speak about atomic energy because atomic are weapons. At that time, it was atomic bomb, but he speaks about nuclear energy. So leaving the word atomic outside because, not to have any kind of relation with the bomb. And he says that nuclear physics has 3 main subjects. One is elementary particle, the fundamental. Then there are nuclear physics, the physics of nuclei. And then there is nuclear engineering. So nuclear engineering is within the realm of nuclear physics. And in these 3 are not on the same level. There is an hierarchy. What the fundamental physics is the most important one. The elementary part of it is the most important one. And there is necessary to develop elementary particle physics in order to transfer knowledge to atomic nuclear physics, and then to the production, the applications. So it links the applications to the research of elementary particles. And this remains in the language in Italy, also in the political realm, in the news. And so all articles, they mix research for production of nuclear energy with the research on elementary particles. And that was the trick that was used by nuclear physics in order to, the amount of money needed to produce nuclear energy is very, very big. And it is important to link the nuclear, the physics research to this production of energy in order to be able to have a part of the money put at disposal by the government. This was the real idea behind that. In 1952, Italy creates a new institute, the National Committee for Nuclear Research. That it is around the production of nuclear energy. And at that moment, it was also only an initiative of industrialists from North Italy to move towards the production of nuclear reactor in order to be able to produce nuclear energy. And they had created a center that is called the CISE, and they in 1951, they had already a project to build up a reactor, but they wanted to have money and support from the government. And the government at this moment, because the Ministry of Industry started to be interested in the field of nuclear energy, decided to start to have some kind of control. And there are 2 personalities, Amaldi and Giordani, Francesco Giordani, who was a person that was used to navigate within the Italian government and institutions. And they decided to create this body in order to be able to control the way to nuclear energy. So at the moment, the only activity for production of nuclear energy, electricity, was in the hands of industrialists of North Italy. This was not pleased by the Italian government and by group of meridionalists and the Ministry of it. So they wanted to put the hands on the research for production of nuclear energy. So this National Center for Research, Nuclear Research, had, different people thought different things about this body. For Campilli and Giordani was a structure within the Ministry of Industry. For Colonetti was a new committee of the National Research Council. For Amaldi was a new rich financier of the National Institute of Nuclear Physics. For the industrialist was a source of financing for the energy, for the production of nuclear energy. So this body was a compromise because it was part of National Research Council, part was outside, and in this way was a lot of possibility of navigation of and contrast of different bodies and different interests. In any case, he got a lot of money, 1 billion lira, that was extremely high at the time. In consequence to the creation of this center, the INFN was reformed, and the main point was the creation of a president nominated by the president of the National Research Council. And from this moment, the money was not given directly to the sections, to the research section, but was given to this central presidency, and had to be distributed after to the various groups. Okay, we can skip this one. This new money that is coming to INFN make possible to build an accelerator in Italy, much smaller than the accelerator at CERN, but in any way the idea was possible to start the research for building a national accelerator that was an electron synchrotron of 1 GeV. That was at the moment financed by the sections, had to renounce to money for this activity, and the project was ready in '54, but at the moment was started a competition where this national device is going to be built. So there were two schools of thought, like in Italy it is normal. It was people from Milan, Turin, Colonetti, the mayor of Milan, were for having it north. But Amaldi, Giordani, Ippolito were to have in Rome, because in Italy the idea Roma Ladrona is a very old one. Finally, the Frascati, mayor of Frascati, gave space, a land, and the group of Rome were able to find 100 million from different sources, and so it was decided to create a laboratory near Rome, in Frascati. The group working for accelerator moved to Rome, and then start the work for the accelerator, and it is created the National Laboratories of Frascati. They are not belonging to National Institute of Physics, but are belonging to the National Center for Nuclear Research, CNR. The laboratory and with the accelerator are produced in in 1958, and 1959, the experiment started in Frascati. Now we are in this moment, there are, a proliferation of activity around Italy, and there are, in addition to the 4 sections, there are groups or under section, and so there are Pisa and Bologna, new seats of INFN, Naples, Sicily, and in 1960, the University of Padua created a laboratory for studying atomic nuclei in Legnaro, and now INFN, with the money of the CNRN, started to also to have its own personnel. In particular, mainly technicians became personnel of INFN, and obviously this creates tension within university. In the meanwhile, in any case, this CNRN, that was meant as an institution to give money to finance, start to be controller of the activities, and the person behind this change of structure of rules is Ippolito, this personality. And in 1960, this big research institution with 1,700 employees and important financing, but without low personality. There are tensions with the industrial groups. There are, and now the basic problem is the policy that is the policy economic contrast about the nationalization of electric energy that was decided by the Socialist Party essentially, and it was it was a situation possible to have a substantial law for the whole part of nuclear research, but finally it was created a new institute, the National Committee for Nuclear Energy, that has some kind of, at this moment, it is an entity of public right. So at this moment, INFN is between NEN and the National Research Council. There are a proposal to have a foundation for this kind of research, but it doesn't work. University is against it. And so, these things, everything is complicated in Italy. But important point that in 1968, we have a first national laboratory of INFN. It is the Legnaro laboratory, became national, while the Frascati remains under the control of CNEN. So this is the situation. In Frascati, there is an important scientific development, the idea to start to have collisions, accelerator to make collide particles and particles in flight. This is a very important possibility in order to reach very, very high energies. This was proposed in Tušek, and the project, the project device was built with immediately. At that time, Ippolito was able to get 20 million lire without any problem. So this is the one of the points that in order to be efficient, you must be able to navigate in the laws. And the idea was finally to build an accelerator specific of this kind for having collisions in flight between matter and antimatter, electron, positron. The device was called Adone, and started operation in 1969. The start operation was delayed because there was a crisis of INFN, because Ippolito was under trial and finished in prison, and there were problems with the trade unions. In any case, in 1967, it was a new restructure of INFN. The INFN was collocated in Frascati, and the structure foresees a president, the council of directors, and in the various institutions. This is the structure of INFN at that time. There are several sections. There is the president, there is the council of the directors, and then Frascati are somehow scientifically controlled by NFN. They are not part of NFN, and this is the structure at that time. In that moment, INFN had very small number of researchers, but because most of the personnel were professors of university, and the amount of money was this is in million lire, so these are 1 billion lire, and in order to have an idea what is today, you must divide by 100, so it was 17 million euro. This was the money divided. At this moment, we have a big change. Claudio Villi became president of NFN and wants to give the NFN a solid personality, legal personality, and a clear position within the Italian institutions and international institution, and give a change to the structure. So in 1971, a law gives personality, independent personality to the institute. Then the idea of Villi is to create national commissions. They have scientific commissions that are giving support in the scientific realm to the decisional organs. There are 5 groups, one articles with electronic techniques, one with the second elementary part with bubble chambers, nuclear physics, theoretical physics, and technical physics. So in this way, all researchers belong to one of these commissions, and the president of commission is elected by the representatives of the groups. And in this way, there are precised and formalized the relation of INFN with other Italian institutions, with the university, with the Istituto Superiore di Sanità, with the National Research Council, with the Committee of Nuclear Energy, and in this way, in this moment, there are also relations with the regional authorities, and in 1975, a second national laboratory is created in Catania. Now we come at the formalization of international relations. 1971, a special office is created, an office for international affairs. In 72, there is an agreement with the United States, 73 with Japan, 73 with the Russian committee, the Soviet Committee for Nuclear Energy. Then there are formalization of the relation with CERN, with the Euratom, and the cooperation with Dubna, Russian, and the Academy of Science of the Soviet Union. There is a contact with Academia Sinica, and cooperation with the German laboratory DESI for research in the field of electron positron. Then, and after that, things change for INFN, money starts to flow in, and so there are several new laboratories are created. There is in Bologna a center for for support of research with bubble chamber that now is National Center for Technology, for Informatic and Telematic Technologies. Then 85, there is created the National Laboratory of Gran Sasso, that is the largest world laboratory underground for research, special research. Then 2000, there is created an observatory for gravitational waves with the cooperation of France. Then there is a laboratory for nuclear techniques for environment and cultural heritage, Florence. Then there is another institute for theoretical research in Florence. And then 1914, it was created the Trento Institute for Fundamental Physics and Application. These are new, big, let's say, laboratories created for NFN. Then there are two other passages important for also the INFN are the law on the creation of Ministry of University and there is a continuing restructuring of research centers, but the INFN was able to pass through this bureaucratic law, keeping the structure that was given by Willy substantially. There are nowadays, INFN, here there are the Italian laboratories and sections, but the important point, and then there are, in addition to these centers, there is research in the major world laboratory. There is now space activity also, but the structure of Willy and the fact that the president of NFN is not decided by the government, is elected by the researchers, that is a point that still today remains. So this is the present structure of the decision structure of INFN. And now these are the money now that is disposal. You see now there are, in 1924, it was 400 million euro. And this amount will remain in the next, will slightly increase in the next few years. You know, it is complete, you know, from 16 to 400. Okay. Now we can see how so now that the INFN is as a structure, it is also possible to have formal activity, international activities. Quanto tempo ho ancora? 20 minuti. Okay. So we have seen that the very birth of INFN is in the international activity. We have already seen. So the spirit of internationality remains all over the life of INFN. The forms of activity depends on the kind of research. So it's different for theoretical research, for particle research with electronic detectors or with bubble chambers, or done where there is colliding beams. Then there is so-called passive research that is on the land or in the space, with passive means without accelerators, possibly with reactors. And then there are the research of atomic nuclei that are of two kinds, of low energy or intermediate energy. And so according to this kind of research, we have different forms of international collaboration. Obviously, there are single researchers can have international activities. This is a typical of theoreticians. Theoreticians usually work by themselves or with 2, 3 groups, very small. And so it is obviously possible that a single researcher start international collaboration all over the world. Another possibility is the researchers in sabbatical can go around and take work with a seat where they are going. another point, another source of single persons research abroad are the lack in Italy for a long time of PhD degree. So researchers had to go abroad to get their PhD, and going abroad in the university, they start cooperation that they remain. So there are also single person international activities in the INFN. But the important is where groups are making experience. So what happens if you want to make an experiment in an international laboratory, be CERN, be everywhere? You must first define the experiment you want to do. Then you must find the expertise to prepare the experiment and make the physics research. You must decide which are the technical resources needed. And at this point, you look around for resources, and you may start the international collaboration. At that point, you make the proposal of your experiment to the laboratory where you want to have the beam at your disposal. At the same time, you must have approval within your section in Italy, because obviously if you want to make an experiment, you need technician, you need the support. Then the National Commission have to approve the experiment. And then at this moment, you start building the detectors in your laboratory. Then you go in the foreign laboratory to mount the structure at the beam. You collect the data. Then you start analysis of data home in the various venues of the international laboratory. And then finally, you publish the results. So, it's not easy. And if you mind that there are not many international laboratories, and in a laboratory there are not many beams, you are in a lot of competition, both inside Italy and outside at the international level. So up to in the 90s, this is the one part of the CERN lab. The accelerator produces several beams. You must sit your detector on a specific beam, which the beam changes by kind of particle that are accelerated and the energy, and you have to build your device there. And this is if you make an electronic, so-called an electronic experiment. Otherwise, the lab builds also a general use detector, in particular so-called bubble chambers. These are big, this is the BEPS, this is the largest bubble chamber ever produced within a magnetic field. And in this case, in this device, there are a lot of, you obtain a lot of pictures that must be, interpreted, measured home. And in this case, you decide the experiment, and then you receive the images to read. See, we know the complexity of the experiment grows with the energy, because there is the Einstein law that the mass you can produce is the energy divided c squared. So with the increased mass, you can produce new particles. For instance, this is the mass in GeV. So around the 1 GeV, you have a lot of particles, but if you want to have a special particle, you must go up with the energy. And when you go up with the energy, the processes are much more complicated, and you need obviously bigger detectors. This is, for instance, a complicated image of an event seen at Alice. It is one of the detectors. The bubble chamber, as we have seen, usually there are hundreds of thousands of photographs. They are, every image is There are 9 different cameras, so you have different views in order to be able to reconstruct the event. You must be visual, so you need a lot of people scanners in your home. And main Italian groups are Milan, Padua, have been Milan, Padua, Pisa, Torino, and the major devices were the 2 meters hydrogen bubble chamber at CERN, Gargaban and BABC at CERN. United States was one big device at Brookhaven, and in Russia in Moscow at the Institute ITEP. And Italian groups, Milan, Padua, Pisa, and Torino, have been present practically in all these laboratories from one period or the other. Okay. So we have seen that also for electronic apparatus, you need a lot of international cooperation because the devices are complicated. There are the main laboratories used by NFN, where practically all around the world was at CERN in Russia, Serpukhov, Stanford, SLAC, Argonne at Argonne National Laboratory, Brookhaven, Batavia, the Fermi Lab, and Dubna. These are the main laboratories with non-colliders. Then there are colliders, laboratory with, this give you an idea of the international activity. These are researches done in Italy in the various years. These are research done at CERN. These are other European experiments, and these are Russian. These are other American and Russian. So you see, these are, the period is 70, 75. This gives you an idea of how important was the international activities of INFN. Then okay, let's give up. In the period of 74, 78, we have that group 1, the particle physicists mainly work outside Italy. This is for bubble chamber, for electronics, and the participation in Italy is much smaller. Then there are, you know, the new kind of machines are a collider, and Italian groups participate in the main colliders in France, Orsay, Hamburg, Stanford, Batavia, Chicago, at CERN, and Novosibirsk. In these colliders, the problem is much bigger than the other accelerator, because in a collider, you can build only 1, 2, or 4 experiments, no more than that, because the beams intersect only in 1, 2, 4 points. And so the possibility is only to have, in these big accelerators of highest energy, you can have a very small number of experiments. For this reason, the collaborations became worldwide. And so at the beginning, some few hundred scientists in just one experiment, and nowadays more than 1,000. And also at this point, INFN make formal agreements with the international institutions in order to support and to have a space at this important. INFN is present everywhere, you know, there is no doubt. But to give you an idea of the change, first there were the single groups going around for having an experiment. And now, for instance, in the case of, this is the first time that INFN makes a formal agreement with these are the American Energy Commission that owns the laboratory at Fermilab. And this is the experiment built there, called CIDF. And you see there are flags. For the first time, you have flex on the accelerator, Japan, United States, and Italy, because these were the major group, the major institutions involved, but there were also United Kingdom, Canada, Germany, Spain, Russia, Finland, Taiwan, France, Korea, Switzerland. All was a very broad international, but with the formal agreements made through the foreign ministry, where INF, Italy, INFN, United States, and Japan. Another example of peculiar participation of INFN to an international activity is HIRA. That was a lab constructed in Hamburg, the laboratory DAISY, was a very special device, proton-electron for interaction of proton and electrons. And in this case, INFN not only participate to an experiment, but participate to the construction of the accelerator. So they built part of the acceleration, and here you see it is Zanon, Ansaldo, Europa Metalli are the Italian contribution to one of the big. So they also built part of the accelerator, and then Orville was part in an important part in the experiment called the ZOIS. There were 400, you know, the numbers are few hundred scientists, 56 institutions, 70 countries, and INFN important role was paid by Padua section. Okay, this is the elementary particle part. The situation is quite different for physics of atomic nuclei, because there are many accelerators, small but many. The instruments are high precision, but simpler, much simpler than the ones for high energy. There are small numbers of researchers in every experiment. INFN had historical collaboration with München, Harwell, Heidelberg, Yale, Saclay, Orsay. And here also we have a certain moment, European groups built a very important detector, very difficult, very expensive, that was called the Euroball. And this was a common project, and this device was moving from one lab to another lab. So the first one, I think, was Legnaro, and the second was Caen. And then it's moving around, and this kind of international collaboration, also in the field of nuclear physics. As the different situation for research of atomic nuclei, but higher energy, an energy between the one of typical, below around 1 GeV, not more than that. And here there are also the experiments are not so complicated as the particle, but much bigger than low energy physics. And there are activities with CERN, Switzerland, Caen, Orsay, Dubna, Jefferson Lab in United States, Grenoble. So there are also these, but the collaboration are limited number of groups and limited number of labs. Then we have started in the 80s, the physics without accelerators. And these research are on the cosmic radiation and the natural radiation. And there are, this kind of research are on very rare events, or in principle prohibit, there are, what is needed are big dimension of the detectors, and the experiment lasts a long time. And in this case, we have a collaboration with the foreign groups. And the first time we have groups that are coming in Italy to collaborate on experiment, in particular to the lab in Gran Sasso, the underground lab under the mountain. And another example of collaboration is the Yangbai-Jing Cosmic Ray Observatory Station in Tibet that was built by NFN in collaboration with the Chinese government and Academia Sinica. Then a very peculiar experiment was made at Gran Sasso. So at CERN was created a beam of neutrini. Neutrino are particles that can pass without being absorbed through very long distance, cosmic distance. So it was a beam was produced at CERN and sent towards the Gran Sasso. And there was a large international collaboration with mainly with the two experiments in Gran Sasso that were looking at the behavior of neutrini coming from CERN. One was called the Opera. This is very complex device. And this one is a second one with Icarus, with Polish, American, and Russian scientists and CERN scientists. This is a different form of research. Another kind of so-called research without accelerators are two other big activities of NFN. One is in Japan at Kamiokande. This was a mine, and they built a lake inside, a very huge lake with a lot of detectors. You see scientists that are checking the detectors on the boat, and this also was as a large participation of INFN. And another one is in Argentina, at the Pampa Amarilla. There are the Observatory for Cosmic Ray of Very High Energy. The surface of the detector is 3,000 square kilometers. And there are a lot, 17 countries and 500 physicists. Another important different form of cooperation is around magic. They are two telescopes of 70 meters of diameter installed in La Palma Island for checking the special radiation that is produced by gamma rays of very, very high energy. And there are now countries collaborating with INFN. Then in the end of the 90s, INFN started also research in space. Instead of waiting for the cosmic ray to arrive on the surface or underground, they try to pick up when they are in space. The first experiment was Nina. It was attached to a Russian satellite. And then research in this field are increasing, and there are international cooperation with NASA and ESA. For instance, this is one, the detector is prepared by NFN, then is given to the special companies. They are able to produce devices that can fly, and then they are put on special satellites and so on. A final collaboration, it is collaboration for detection and measurement of gravitational waves. In this kind, you need different labs distributed over the whole Earth that work simultaneously in order to pick simultaneously a signal coming from sources, special sources, collapse of black or neutron stars and so on. And in Italy, we have seen there is a detector. These are 3 kilometers long, an interferometer near Pisa. And this is the central mirror. And this is a connection with the LIGO devices, similar devices in the United States, and they have been able to detect the first, and now they are continuously detecting gravitational waves. Okay, that's all. Thank you.
for this fascinating historical overview of the activities of the INFN. I must say that this is for, I mean, thinking of students who are here in this room, I think this can be an excellent case study for studying the development of a laboratory starting from the post-war times after the end of the Second World War, the beginning of the development of a scientific community in the 50s. However, drawing on a tradition that had already started in previous years, this idea of epistemic community is very, very important. And also this notion of epistemic community can be applied also to other contexts. And I think this is an extremely useful analytical tool to reconstruct networks in general. So for you as students here, I think that many of the dynamics that Professor Pascolini has described can be also applied to other contexts, to other potential case studies. And I also believe that the interlink between internal politics, international politics, industrial apparatuses has emerged during your presentation. For instance, as scholars of international relations, we are used to focus on foreign ministries. Whereas in your presentation, especially at the beginning when the INFN was developing, you referred to the Ministry of Industry, for instance. And you see also the interlink between, for instance, internal dynamics, that is, for instance, in the 60s, the Italian Socialist Party being part of the governing coalition, the decision to nationalize electronic energy, and the impact this had on also the scientific community. Then another point that I noted out of your presentation, the role of Claudio Villi as president of INFN between 1970 and 1975, and among the parties that were involved in the internationalization of the INFN, you mentioned the USA, but also the USSR. So as Cold War historians, as myself also, David Burigana, also Carlo Patti is here. So scholars who have been focusing on different aspects of the Cold War. Probably this gives you an idea of how ideological barriers could be overcome and cooperation could be launched, major instances of cooperation, even in times of Cold War, of nuclear confrontation, and so on. So this idea of overcoming the Cold War can also be perceived also from this case study of the INFN. So maybe there will be other questions or related to the presentation by Alessandro Pascolini. And I would now continue with our panel by giving the floor to Dr. Francesco Grespan, who is actually someone who builds accelerators. So he is now involved in several projects, and let me introduce him so that you have a sense of the perspective from which Francesco will be speaking and delivering his presentation now. So actually, Francesco studied the classics in high school, but then he moved to hard sciences. He got his degree in physics in Padova in 2006 with a master thesis at INFN at the National Laboratory of Legnaro, one of the laboratories that Professor Pascolini was mentioning in his presentation, focusing on RFQ accelerators. Maybe you will be able to say a few words about that, because I don't dare to do that. He then got his PhD at Milano University. He developed his thesis at CERN in Geneva, so a dynamic that Professor Pascolini was also mentioning, so individual scholars spending periods abroad and started to enter into scientific networks on DTL accelerators that he defended in 2010. And now he is an accelerator physicist at INFN LNL, so that at Legnaro Lab near Padova, and he has been involved in several projects for designing, constructing, installing, and accelerators. They include one project in Japan between 2007 and 2019. one in Lund, Sweden, where he has been staying, I mean, traveling across Padova and Lund for many years now. Another project for a cancer neutron therapy center in Caserta, Italy. He is also been involved in another project named Piave Alpi Complex. But beyond being a physicist, he is also a piano player and also a father of 3 young kids. So we actually met for the first time for this very reason with the kids, but now I'm very happy to give the floor to Francesco for his perspective on present-day projects on which INF is involved, and you will see how science diplomacy will be popping up.
Hello, thank you for inviting me to. It has been interesting for me to do this, prepare this speech, because I'm scientist of accelerator, so I'm involved in the construction and not really in the negotiation, except when they becomes negotiation on technical parts. So I tried also to check my sources of information about the historical part, and I think it's okay there. And
the screen.
okay, sorry. Because they're not looking.
Yeah.
Okay, sorry.
Okay.
I will talk about 2 projects to give you a flavor, I hope, of how these big projects for accelerators, for building accelerator, born and how they are developed and how they are built. There are 2 cases in which I took part. One is the so-called IFMIF project, that is the International Fusion Material Irradiation Facility. It's easy to understand, that is related to fusion energy production. It is a 10 megawatt accelerator. 10 megawatt is the power of the beam, so it's very powerful accelerator. There is a prototype now installed in Japan to demonstrate the technology of this, but the case of fusion energy and the related project is very interesting, I think, for your perspective in particular. It complicates and never arrive to an end, and always there is something that must be added to the study, so we will go through. The other project that has been much more linear is the European Spallation Source. It is another big accelerator, already built, because here you see a picture in south of Sweden, in fact, that is Lund. And it is a 5 megawatt, so half of this power. If we look, the physics like plots and graph, but I promise only one. If you see, this is a plots that put together on the ion beam energy and the average current of accelerators. So you see that in this, those are the ISO power lines, we call. So all the accelerator on these lines has the same power. You see that ESS and IFMIF are really very, very powerful. The more powerful linear accelerator ever built. And this, just to say, this is the complication and the cost of the projects that is inside this number, that is the power of the beam. And here also in this plot is interesting to see how they are grouped. These very powerful acceleration are for fusion material technologies research. All this big group is about material and life science, or applied science. And then there is the group of elemental particle physics, where also Tevatron, you see, stay in this line that has been mentioned by Professor Pascolini, that is located in Chicago. So I try to build a possible common scheme for this project. That I must say, I talked to this after the invitation of David, and and Benedetto, because I'm typically busy on physics and not on looking how the projects are built. But I think that they should be correct. So there is a first phase which regard these three main tasks, the definition of the user and the first design. So everything starts if there is someone that wants to use the accelerators, otherwise there is no reason to build an accelerators. And together with this, the physicists started the very first proposal of design. You hear just now many examples from Professor Pascolini. Then there is a definition of the related infrastructure. So what is needed to do this research or to make the user happy? And then the first design studies, a bit more, let's say, even engineeristic side wise studies. So this first phase, it is developed by somehow spontaneous working groups that work between institutes and universities and that are linked together for many reasons. And they ask, let's say, funding to their own institutes to participate to this very first phase. There is a case ongoing in this phase, in this moment, that is the muon collider, that is under these studies, not decided where, how, who, but there is many scientists in Italy, in Geneva, in Europe, in USA are working on that, even if it is not defined. Then the second phase, somehow it becomes in the hand of the ministries and the international boards like European Union or the agencies of European Union. Here I mentioned the ESFRI, that is the European Forum for Research Infrastructure, that approved in particular the two projects that I'm going to work to explain or to tell you. So there is in this phase, the ministry is the player that plays the candidate is country to host the experiment, the accelerator. And after these decisions been taken, that this happened, this international board with voting between ministries or delegates of ministries, the contributions from countries, so each country should contribute to this international project because they are in this, let's say, constructing phase and definition phase, and very rarely people withdraw his own participation, maybe they calibrate, but the contribution is decided by the ministry and the government. And this is the moment where the real money is decided. I mean, the money for construction, that is the big amount of money. And then there is the definition of the technical contribution that is many times defined as an in-kind contribution. So the country built, in fact, part of the object. That is also a way to develop the national industries or the know-how and strategic competence of the countries. And in this moment, the balls come back to the institutes that as the specialists, in this case, accelerator specialists, and propose which part of the machine is interesting to build. And this is a negotiation between the technical, the scientific institutes and the hosting organization. That it can be an international organization like CERN, or it can be like HERA, DAISY, is a national lab that received from Italy, for example, part of the accelerator that is forever installed there. So this is the possible scheme. Now I try to demonstrate that this scheme works, and this a way to interpret this construction of projects. So the first, because it is more linear, I start from the European spallation source, even if historically the fusion case is precedent. So the users of the European spallation source are in fact the scientists of neutron scattering. And they were very active in the 80s in Europe and all around the world, asking for other source of neutrons than the reactors, because the reactors are natural source of neutron where these scientists can bring their samples or whatever it is and studies science of neutron, physics of neutrons, or material science. but they wanted to have also different sources. So there was a case that was the UK case of ISIS source in Rutherford Lab. It was the very first spallation source, I guess, in Europe in 1985. And this was an extreme success from the scientific point of view. So in 1993, the Neutron Scattering Association, so there is an association of neutron scattering science, became the advocates to have a spallation source in Europe, the European spallation source. And the same debates started in all the countries around the world and the other continents as well. In particular, after this success, the first design studies started in Europe for the European spallation source. And I printed here, this is the extract of a CERN Accelerator School of 1996. I didn't took part because I was at the high school, not with Benedetto, that is much younger than me. And there is inside there, part of the lecture was on the European spallation source design. I think you will get the slides, you will see here. Professor Langeler of CERN was the leader of these studies on the European spallation source in Europe. And there is a famous paper of 96 where it closed this very first phase of the design and it mentioned only as acknowledgement the other colleagues that contributed, just to say that was a spontaneous effort of the people. Probably they were paid, the travelers were paid, the computational study were paid, but it was recognized, but nothing really structured. In 1999, the Organization of European Economic, I think, Cooperation and Development. You are the expert on that, David, please help me.
No, yes, this is very nice because I try to explore your fields and now we have a trap for you with the name is Organization
of Economic Cooperation, economic, yeah. I think is something UN, is not only European, and they make a studies, look to the needs.
I'm sorry,
No.
because your professor remembered me that it was impossible, like the acceleration of neutrons. No, this is European.
It's European.
Yes, but it's very nice that you have this discussion in this organization because it changed the name in 1965, 1966, became the Organization for European Cooperation, Economic Cooperation and Development. And 1965-66, we have the first debate about the technological gap. And this organization, more and more, will be interested in science, technology, not only in economics. Thanks so much. But
good, thank you. No, here to learn. So they wrote a report where they mentioned that the needs is to have one spallation, neutron spallation source per continent, meaning North America, Europe, and Asia. So immediately in 1999, US and Japan approved their own the construction of, there was already, of course, something growing up since before. They immediately approved their own spallation source. And so the construction of this powerful acceleration to produce neutrons, not to accelerate neutrons, to produce neutrons, right? And Europe is much, let's say, slower typically because we have important councils to discuss and we have to take decision democratically, and we didn't have at the time central government, or still we don't have. So we started a bit later, but this gave us some advantage at the end because now the spallation source, it is much more powerful than the two already built because we also took many lessons learned. So after that, there was established in the 2002, I think, a design task force that between 2002 and 2006 defined the best configuration of this accelerator and also of the target to produce neutrons. And this design task force was European based and took idea from many other collaboration already ongoing. So there was you see here, I make a list of projects, of design project at the end, that has been never built because the Super Proton Linux CERN has never been built. The Tesla somehow it has been used as technology development to build HERA and also to build then the laser, the electron laser source of DAISY. But they were, let's say, technological and R&D project of accelerator science. So at the end, in the years of the 2000s were spent on that. And in 2007, 2008, the ESFRI received the application of 3 countries to host the spallation source, Hungary, Spain, and Sweden. In 2009, a meeting of the ministry in Brussels selected Lund as hosting city. That is the city that has been proposed by Sweden. In that vote, Italy, Spain and Hungary, in fact, withdraw their applications to support because they understood earlier that they are going to lose. And I think so, that is somehow confirmed. And Italy and I think Switzerland, I'm sure about Italy, they declare at the beginning they would have voted with the majority. That is a very clever way not to decide. And in 2014, Italy decided to contribute. So the cost of the provision of the cost of the facility was 2 billion euros. And Italy decided to contribute with 100 million euros. 33 of that were for accelerator. So then for accelerator in Italy, there are 2 institutions. One is INFN and the other is Elettra that are experts of electron accelerators. They are based in Trieste, Basovizza. They have a very nice lab. And so INFN decided to participate and they took from the cost book of ISS the ion source and the drift tube LINAC and the superconducting cavities. Why we decided for these 3 components in particular? So looking to the story, I think there are decisions that are taken because we already have a know-how, a strategic know-how that we want to maintain. And this is the case of the ion source, where the lab of Catania, that Professor Pascolini mentioned before, they are expert on building that, and Milano, they built HERA, and so they are expert on superconducting cavities. They wanted to have a next project on that. And also, these big projects are also the opportunity to develop a new strategic component. And this is, for example, the case of the drift tube LINAC, where I have worked, I did my PhD thesis at CERN on that accelerator, but has never been built in Italy before, a drift tube LINAC. So this is more or less the negotiation that we took with the other institutes around Europe, like the Commissariat Énergie Atomique in France, or the GSI, the lab of close to Frankfurt, Darmstadt. So we talked together and we decided to ask to build that or that other part based on this consideration. So going ahead, we go to this fusion. So I think for science diplomacy, this is a very good case because the fusion energy is interesting. So the first milestone that there is already something before, but in the 1985, the Geneva Superpower Summit, Reagan and Gorbachev proposed to build an international collaboration to construct a unique fusion reactor demonstrator. The 20 years before, there was already something ongoing, not 20, no, maybe 15. but each country has his own tokamak, his own reactor. And this proposal came, in fact, from Gorbachev. It looks demonstrated that it was Gorbachev that arrived that summer with this proposal. So together with the proposal of the fusion energy, has been decided, in this case, many infrastructure to approach the fusion reactors, because it is something very difficult, even if Sakharov gave the Russian scientist that found the solution for this tokamak, gave a very good input at the beginning, but technologically it's very difficult. So one is ITER, so-called International Thermonuclear Experimental Reactor, that is the reactor that should demonstrate that the fusion in this tokamak, in these big magnets, is stable and can be maintained. And the other problem to solve is to solve the materials to be used, because this very big amount of neutrons that are used in this, that are produced in these reactors are very dangerous for the material, that it becomes weak very quickly. And so the IFMIF project, it is in fact an accelerator project to produce neutrons with the same energy and the same flux, the same quantity of neutron of a reactor, to study sample of material to be used. So immediately the community of scientists recognized that need two ways. One is to demonstrate the fusion, and one is to find the materials to build the real reactor, because a reactor cannot stay a few hours and then become useless. It must work for 20 years and so on. So I let ITER, even if it is the most important project nowadays on the fusion, because it's not about accelerator. About accelerator is in 2003, there was, in 1989, there was the first IFMIF workshop in San Diego, and all the world was involved. So there was United States, of course, Russia, Japan, and Europe countries. And in 2003, the conceptual design arrived. So we arrived at the end of the design studies. And this is still the design that is now going on. So two parallel accelerators. To produce this 10 megawatt, we need two parallel accelerators that then are merged together and go into the target as a single beam. This is to say that ESS is a single accelerator, but if in fact to go to the next decade of power, need two accelerators, it looks like. We never found another solution up to now. About the phase of negotiation between countries, so somehow was in the discussion that the continent that hosting the ITER reactor would have not been hosting the accelerator experiment. So when in 2006, the ITER agreement between China, Euratom for Europe, India, Japan, Korea, Russia, and USA decided for Cadarache, so in France, to build ITER. So another agreement has been signed immediately after, a few months in fact after, that is called Broader Approach Agreement between European Union and Japan, to build all the complementary activities in Japan, in particular the prototype of the accelerator. So we are still not going to build the accelerator, but the prototype of this accelerator to studies material science. Italy contribute to this broader approach. To ITER is much more money, but to the broader approach with 90 million, 25 of this for the accelerator. And about the strategic development for INFN, at that time it has been interested for INFN to construct the radio frequency quadruple, which was somehow the first of this kind, so powerful that because there was a single example already built that was in the United States. But for Europe, this technology was still in development, and INFN had the most advanced development of this technology. We, in fact, built this accelerator that is in my first slide, I think, is this one that you see here. and installed and commissioned until 2019. Also, the accelerator for ESS has been built and installed. Now I go to the last slide, I think, yes. So this approach to fusion, it becomes more and more complicated, even because of many delay, technical challenges, maybe some mismanagement. And another step has been decided many years ago after ITER, that is the demo, the demonstrator of the fusion reactor, that is not yet the plant to produce electricity to give to the countries, but it is another demonstrator. So together with this, also the accelerator projects invented another steps. And in 2015, Europe, so there was some, in my opinion, look into the past, looks that IFMIF should be built in Japan because of the previous discussions. But Japan was a bit hesitating. So Europe took the initiative and say, okay, we built half of the IFMIF to demonstrate this demo reactor materials. So 5 megawatt accelerator, the same size of ESS. And this project, project start in Europe. We immediately start from the engineering phase because the prototype has been already designed and installed in Japan. In 2017, Croatia and Spain candidates the countries for IFMIF DONES, so this alpha accelerator. And in 2018, the Agency for the European Union Fusion for Energy, that is somehow the main actor of this fusion, all these fusion projects, decided to go to Granada, so in Spain. And so the site has been decided. This fusion for energy in the council, there are the delegate of the ministry. So at the end, it has been the ministries to decide. This enter in the European strategic infrastructure roadmap, and Italy in 2024, in July, confirmed the participation with around 65 million euros, 25 of that for accelerator. I reported this news from the website of INFN because INFN never confirmed his own participation to this project until Spain didn't confirm the participation and the support to Italy as hosting countries for Einstein telescope. So if you read this news, if you type INFN Einstein telescope in the Google, you find this news where you read everything. There is this picture of the ministry with our president, Antonio Zoccoli, and you read everything about Einstein Telecom with the last 4 rows here are about the fact that we also, on the other hand, we give support to the donors. So this, I think, is an example of diplomacy playing on this doubt des on science. Again, here, what we are going to build as choices, we are going to build the radio frequency quadruple because we already demonstrate that we built the previous one. And as we mentioned, this is somehow we want to start this project from the engineering phase. And then we also take part of the superconducting LINAC. We share with the Commissariale Energie Atomique the production of this long superconducting LINAC, first because of the complexity, but also because INFN is interested on this new kind of cavities that has been developed on this prototype and to have back the technology of this. And I think this is the end. I listed here my references. I have 2 talks from colleagues. One is Professor Pisent of Padova, and another is Masayoshi Sugimoto that has been in the IFMIF projects in the 70s. So he participated to the very early meetings and is now retired, but he gave a nice historical talk. And then you see that all the rest is you can find in the websites, in particular the website of European Union. They report all this stage of decision very carefully. And this is my last slide.
So thank you very much, Francesco, for this another yet inspiring and much detailed description of two major projects of INFN. So we were seeing how things are developing now, but also thank you for adopting this long-term historical perspective. So I mean, I was amazed to see Gorbachev and Reagan launching this major project. And going back to what I was saying before, we see how these instances of scientific cooperation can pave the way to broader international agreements. So they are parts of actual international processes. So I don't want to take much more time. I would have other maybe questions to ask, but first of all, I would like to ask if there are comments, questions of any kinds, because this is a kind of multidisciplinary panel. And so every kind of question is allowed.
Okay, we ask only to came here, say the name.
Carlo Pacigalupi, Sissa. I apologize in advance because I will have to attend a teleconference at this moment, so I will pay little attention to the discussion later. But my question was for Professor Pasquali, in particular for the developments of the INFN, which is supporting at this moment many missions that we are following and many projects that we are following. So we are particularly thankful to the agency and the institute. And so my question is really naive concerning your vision of the integration of the INFN and similar agencies and institutions in Europe. So are you guys happy about the level of collaboration which is there? Would you see more power into the communication and making the institutions more flexible and more quicker in interacting to each other at the continental level? How do you see these things ongoing?
I would have a round of questions. And so we can maybe, thank you very much for your question. So maybe we can collect another one or two questions and then the floor to the speakers.
Yes, hello. My question is for Francesco. Yes, so I'm João Tengur. I'm a researcher at the University of Bergen. So my question is basically, so of course these projects, they involved a great deal of advanced technology. And my question is basically, how is this recent developments and this recent environment that tries to limit the sharing of technology and this dual use research, how is it affecting the development of these projects? Yes, the development of these projects, if the procurement is limited, if the range of partners that you can include being limited, etc.
And my question is for Alessio Rocci, University of Brussels. My question is for both of you and in general. I noticed in the talk of Professor Pascolini that the various agreement with other nations came after, of course, for example, the collaboration started between single scientists and so on. And I was thinking also in the other talk about this idea of developing these kind of agreements in general. So my question is, you that were working inside this association, what was the degree of commitments of the single scientists? What was the contribution to to achieve this kind of agreements, was there maybe a bottom-up contribution from this or not? And also in the context of the old Cold War, was there a difference in behavior before and after this kind of agreements? Thank you.
Maybe we can keep the question for a
Yeah,
second
for the-
round. Otherwise, we
Yes.
accumulate too many questions. So I would start from Professor Pascolini, please.
I have first-hand information of what was happening in the 70s. To answer you, that time, you know, in France, there was NDP3 special within the various activities, was a special institution similar to NFN. Was part of the CNRS, but it was, and the cooperation with this one was very, very strict. In major problems of INFN abroad was CERN. It was not easy to be, INFN was not able to be recognized by CERN as the real interface with the Italian scientists. CERN dealt directly with the Italian groups, and most at the moment when the SPS started, INFN tried to decide centrally the participation to the super proto synchrotron, but it failed. I was part of the commission created. We worked 3 years, but at a certain moment, the direct connections of groups directly with the CERN would, destroyed the program that was set up centrally. So that this was a very special, clear indication that it is difficult to have a centralized control of research, the groups. And the national commissions were more important than this super commission. So, this gives you also the internal competition within INFN, and the commissions had directly connection with foreign similar things. So, this changed also over the years and the personalities that were involved. About the second question, it was for the same reason. It was both from top up and up down, because every group had his own collaborators abroad, and we are built up strong cooperation and personal relations. We spoke about this community, epistemic community, but inside community was sub-communities, and various groups have a very good relation with the several groups. And so there was a pressure from below to have some formalized and cover cooperation form. But as long as INFN had not formal personality, it was impossible for INFN to make direct agreement, because there was not a body substantial. So they had not the power to sign or to build up an agreement. Things changed with 1970, with the formal recognition of as an independent body, we subject to the law. And so at that moment, it was possible to take this request from below to build on that and construct international formal agreements. Activities, for instance, in Russia, were also present before because of direct connection with Russian scientists, in Dubna in particular. But after the agreement, it was possible to have a formal participation with all the advantage you can have in Russia at that time, to be formally invited by the Russian body. It was the same in Serpukhov, it was the same in Novosibirsk. So the things completely changed. So it was important to have these cover agreements that make possible everything easier, from passports to build, to, you know, possibility to live, to have a, so but there was a very strong request from below, and that was understood, and the important moment was the creation of this office, special office for international relations. It was in hand of very good diplomat from the very beginning, who died last year, by the way, but it was a good friend. And, you know, in this way, it was possible to have a formal and substantial activities. I take advantage to have a question to him. Yes, I know that there is a second big program for a neutron, strong neutron source, the program for burning the reactor.
A reactor.
Do you know
Ah, the-
Eurotrans, the MIRA?
The MIRA project, yes.
Are there relations between MIRA and the ESS?
So, not directly, no. Okay, I can answer. Yes, and the MIRA project is another CW accelerator. The very first idea was Italian, because Carlo Rubbia proposed in the 80s, in the 90s, the TRASCO, Transmutation Scorie project. And it is mentioned because a lot of technology, in particular on superconductivity, and this very powerful radio frequency quadrupole, where I also graduated, comes from this, the necessity of develop this technology comes from this idea of Rubbia. And nowadays, there are two big projects. One is Chinese, they call ADS, so it is an accelerator. They started, they built it, gone. And the other is this MIRA, European MIRA project that is still in the design phase. But I think they took many development that has been done for ESS, but they are much in an earlier stage. I hope I answer. And Italy is not directly involved, by the way. Italy is not, for the accelerator, we are not directly involved as INFN, and neither as Italy. I don't know why. We are busy somewhere else. So yeah, I try also to reply to some questions. So if we are happy about yes, I think we are happy about the level of iteration between institutes. In particular, for my case, I was a young PhD student, but this bigger collaboration gave me a lot of links and possible iteration that they are still ongoing. We were somehow all focused on the same goal, like the quest of the ring. And this also make a strong community of high power accelerator physicists in Europe and also abroad. About the procurement, yes, it is a problem, the present situation. It is a problem, in particular, the prime materie prime, the raw materials and the rare earth, the niobium procurement for the superconductivity. Yes, it is a problem, the procurement. From the scientific point of view, I think not yet, because it has a more inertial, but somehow the decreasing of exchange, in my opinion, will become a problem with China and Russia in particular. And if we have contribution to the agreements, yes, in particular INFN, thanks to Claudio Villi, has a very democratic working way of work. So we are consulted by the management of the institute to understand what is interesting to do for us. This is the last phase of the negotiation that I mentioned. So after the big agreement between ministry, how much Italy can contribute, we are consulted to understand what is interesting to build for our, also to develop our research.
Okay, thank you very much, both of you. There may be a last round of questions. If you want to come here, thank you.
Yes, this is a question to Professor Pascolini. A question which doesn't come from what you explained, but which I picked up in the way you were introduced by our moderator. I could understand, if I understood well, that you are or were a member of Pugwash. Okay, so yesterday I mentioned in my presentation the Pugwash movement when I tried to answer the rather difficult question, which was how much and how far can scientists contribute to peace building and contribute to alleviate international tension and mitigate conflicts and etc. So I would like to learn about your experience on that. I tried to explain to the students yesterday that in order to be influential, scientists should go beyond their purely scientific role and try to make a step toward the diplomatic sphere, toward the sphere of the decision makers. So what is your experience of that, and how could we assess the effectiveness, the true influence that your movement could have over time regarding disarmament and other related issues to arms, nuclear armaments? Thank you.
Thank you for the attention to Pugwash. I think historically, Pugwash had very good results because for a long time, up to 1990, scientists were consulted by the government, and there were positions at the level of the president and in the United States and the secretary of the Communist Party in Russia. There were positions of scientists, and in Russia was the Academy of Science that had a very strict relation. There was the Institute for United States and Canadian Studies, where practically was the instrument used by the Soviet government in order to deal with scientists, similar important scientists in the United States and Europe. There was a special commission of very important persons that worked on preparing the basis for agreements. In particular, Pugwash was important for the ABM treaty, was largely discussed by Pugwash scientists and brought to attention of governments, American and Soviet governments. Another important work was about the chemical weapons agreement that was largely worked out from the technical point of view by Pugwash and the groups created around Pugwash. Another moment that was important was in the contacts with North Vietnam that was made possible by Pugwashists that was friend with Ho Chi Minh, direct friend. So it was possible to have, connect. These are informal connections, but important that passed to Pugwash. And another moment that was important was the treaty prohibiting underground experiments. That was the Comprehensive Test Ban Treaty, because research was promoted by Pugwash to demonstrate that it was possible to recognize tests made at intercontinental distance without using local instruments of observation. This also was in result. Things changed with the new, a big change was the first Bush government in United States, and the corresponding Yeltsin, the first, the change in the Kremlin government after Yeltsin, and at that moment, the role of scientists, and so also the role of scientists working, acting through PAGOS decreased. And now, I think since the beginning of this century, the real, role of PAGOS has diminished a lot. But still now there has been a big change in PAGOS. We have a new Secretary General and a new president, and it seems that the interest will focus again on the central problems of nuclear competition, because for some 20 years there was much more attention to Pakistan, India, this kind of problems that are not central to the experience and the expertise of power scientists. But now I think it is a restart of interest. But what is missing is the direct connection with the real power positions. That is what has mainly changed. Thank you.
Thank you very much. Is there any other comment in this regard? Maybe Carlo Patti wants to add something.
Just a comment last issue, because I was a little bit surprised, because I mean, Pagos and my friend just passed away, Sergio Duarci, was a prominent. Yes, he passed away in late July, but he was, I mean, one of the main promoters also of the campaign for the treaty for the prohibition of nuclear weapons. So it was an important voice, and I think also that Pagos has had an important role. But on that issue, that I think is the limits that now we are facing also to a possible actual disarmament with a future goal that is not achievable probably, I wanted to go back to the Italian case. And in all these very interesting story about the birth of the INFN. Sorry, I didn't introduce myself. I'm Carlo Patti from the University of Padua, but I've just come back from Brazil, so it's for that I have this strong connection with Sergio. What was the role of the military in creating a nuclear complex, let's say also in the scientific, from the scientific point of view, national institutes of physics? There was a role, there were limitations, there were also elements for stimulating the creation of this, of a unique institute, or not?
No, in Italy there was no relation of military with INFN, and also no relation of military with nuclear energy for production of reactors. One CNRN, Ippolito, at a certain moment took contacts with the military in order to have them interested in the production of reactors, and the CAMEM was created near Pisa, but military wanted to be out. They were only interested in protection, eventually, from the militaries from nuclear attack. That was their main interest, and they refused to be. A position was offered to militaries in this CNRN, and they refused to sit there. And then they wanted to be out of and they have no real contact with INFN. there have not been, I don't remember any program made with militaries. Certain moment, INFN was, in particular, Lignaro was interested in using neutrons for detection of mines, anti-personnel mines. There was some research, but never reached the stage of being formally, considered by the government. And there was some involvement. For instance, Navy was involved in 1952 and 53 for recovering the balloons from the sea. So some kind of cooperation, technical cooperation came occasionally, but there was no real connection. Military in Italy wanted to stay out. The situation is very different from France, where the CNRS, they have nuclear weapons, and also in United Kingdom and United States, but not in Italy.
Also because perhaps Italy and France had a different foreign policy, different limitation after the end of the Second World War, and also the influence of leftist, or the Communist Party was different in the university in Italy and the university in France. This is very important also to understand that now perhaps is not so well perceived, but also in Pugwash, also in other experience, also when they started to create CERN and also European Space Agency, the idea was aiming from the center left, and the idea to a dialogue for peace. And this was possible in Italy because Italy has no engagement in NBC armaments. France was completely free, and she was free also to develop a nuclear power, because we must to say that when you study, but perhaps I make a fake news, but when you study nuclear for civil or military, you have a very nice moment when you may or create the bomb or create the reactor, if you want. This is knowledge, no? And I think this is a very important element to understand, to recall. This was the Cold War also, a different approach, not only between East and West, but also inside the country. In our countries, we had a very important, strong, influent Communist Party, a very strong, influent, in a positive and negative way, trade union. And this is we have in our national television a very nice movie about Berlinguer in 1970s, with several messages. For this is reason I think this example is very nice also to interconnect contemporary history, the history of international relations in 1970s. I may say that before the Russian invasion of Ukraine, we discovered some documents in the archives of the Academy of Science in Moscow, where we had several reports about Italian scientists coming in Russia for space activities. Sure, you have propaganda, you have political control, etc., and also exchange of knowledge. And this was before the docking in 1975, that I repeat, it was, I'm sorry, a fake example of international cooperation. First of all, because it's bilateral. Second, without real technoscience consequence. I think one of the best examples was the Armada for Comet Halley, starting the idea in 1978, realized since 1981, and we know that in 1983 we risked seriously a nuclear war, and successful mission in March 1988, sure, in a new phase of the end of Cold War. We quoted ITER is 1985. It's not hazardous that Gorbachev suggested this. He has in mind also to re-enter the troops from the Central Europe. He had to change, no, the cap, and the ITER is very important, and also for President Reagan. Then afterwards, they engaged the other countries, but afterwards, they starting from a bilateral, no, discussion. With the Comet of Halley, the bilateral discussion started between European Space Agency and US. US left the project, and then is European Space Agency, European countries continue the negotiation with Soviet, and Soviet will launch two probes, Vega 1 and Vega 2, with the cooperation of French scientists and Western German scientists, no? In my opinion, this is a very nice international cooperation, but I came back and then I leave to Alessandro. This real political clash, no? There are many studies on this, from the history of contemporary history, also in history of international relations, also inside the Italian people, sometimes where there was this clash, no? Between left, right, and the very important role of the Catholic Church. We recall Vietnam, we must recall the unsuccessful mission of Giorgio La Pira with one of his young Professor Primicerio, and also the consequence, political consequence for Amintore Fanfani, no, in 1960s. But at the same time, Italian diplomacy with the ambassador tried to facilitate this mission. And it's very nice also this contact for scientists. And I think now is very hopeful. Why? Because we must to go back in the middle of 1960s, acceleration since Kennedy administration of the US military in Vietnam. I quoted June 1967, the contract of Augusta for the production of Chinook helicopters. Italy was engaged. March 1966, a very nice contract for Aermacchi to sell about 50 planes for training to South Africa for training, and we have the letters where Aldo Mori and Nenni said, okay, but it's for training. Alitalia has only 6 planes for training. They ask us 60 planes. If you want, you may read my article. I explain why at the end they have this bill. But this is very known also in Europe by the historian of aircraft cooperation. This is a very nice period, no? In the middle of 1960s, technological gap. I stop here, I'm sorry, I'm too much enthusiastic, but technological gap in the middle of 1960, which is the story, the fabula. It was started in France thanks to the book by Servan Schreiber, no? Les Défis Américains, published June 1967. It's not true. Amintore Fanfani launched letters to the Minister of EEC and Minister of NATO to say, but why we may organize a Marshall Plan for technology, civil in European Economic Community and military in NATO. We want to speak about this where in OECD, the Organization for Economic Cooperation and Development. It's very nice, no? And also very nice to see how Italian scientists were engaged in this process. I'm sorry, but to speak with you is like for me to go in a very nice archives and to discover several. No, you know, because, okay, you know, because some years ago I asked you and you publish, this is for Pier Bruno Ruffini, a very nice article on XXI secolo, a journal of Fascia, about your experience, your witness as member of Pugwash and one of the founder of Isodarko. And anyway, I don't play violin. Thanks. And no, I had also a question for Crespan, and then I finish because thanks so much for your intervention. No? Why, in my opinion? Because you had explained very well, very nice, no? This timeline and this institutional line to explain very how a project, an infrastructure is constructed. I may announce that in Europe we have an idea to study how the infrastructure are launched in 1990s, no? And also your infrastructure. And the question is very simple, very brief. But when you participate in this project, do you have more than an idea, an image, a sensation that you are making foreign policy, or that you have also a political role for your country, for Europe?
Yes. Yes, I think it's clear. It's clear because of the discussion that happened before the construction. So it's very clear that there's been a negotiation, that something is partially under disclosure and something else is that can be shared more easily. So yes, we have the feeling to be ambassadors somehow of our science or technology and in general our country. Yes. Also to keep a good relationship somehow. So it is a delicate role scientifically for the country, but also to build something for the next, not to cut bridge.
Also when, for instance, why to make the choice for Lund, perhaps some government put a lot of money for this sometimes, no?
Yes. In general, the hosting countries pay, except ITER, that is too much. The cost is very high. So France contribute 20% for ITER. But for the IFMI, for the ESS, the hosting country always promise 50%. I had a discussion with Benedetto many years ago. So in the 2009, it wasn't clear the effect of the economic crisis in Europe. I mean, for the public, for me, maybe for you, yes. But Spain had a very strong economic crisis, and the decision was taken just before that this appeared to the public. So after with the con la ragione del dopo, insomma, yes, at least in my mind, maybe there was in the ministries, there was already some signal that, because, for example, Spain was already in the other program, in IFMIF, and they had a very long pause of the funding. So they had 5 years where the funding were frozen at 2008. So they weren't able to go ahead with procurement and so on for many years. And this is also part of the delay. Then they solved it and they recuperate also the delay. But maybe in this decision there was, this is maybe a theme of research. I don't know if there is something written, but it wasn't clear to me that the selection was to Lund, because Bilbao make a strong application with a lot of money. But maybe there was some indication.
Sometimes, perhaps, if you want to construct a telescope in Europe and you have 2 countries for the place, for the site of this telescope, one of these countries may give a lot of money, but the other may decide to play the scientific card and to organize a coordination with the networking activities with his national scientist to organize a maneuver at international level to convince that the best site is inside perhaps a very nice island for seaside with old mines and to place there the telescope also if this country put not so many money than the other one. But this is an important.
We have the legacy of the Pisa telescope, the antenna of Pisa. So we have the legacy of this gravitational antenna that already worked and partially won the Nobel Prize. Scientifically, I mean. No, you mentioned it in the Cascina.
Very well. So, as the coordinator of this panel, I would like to thank the speakers, both Professor Pascolini and Francesco Crespan, for their participation. And I do think that many ideas emerged during this panel, and for scholars, but also for students, it was clear that there is so much room for research about these topics. And so, that said, I wish you a joyful evening, and thank you also for you for participating and making so much interesting question and for contributing to the panel. Thank you and bye.